or, 60% or something like that. You make that eyeball estimate and maybe use your calculator and then add that up with the other areas in here to make a best guess. You might be surprised how close you get. Now here we leave the 68, 95, 99.7 rule and we look at doing it more accurately with the help of a calculator. The calculator is really great for finding the area between any two, a lower and upper endpoint on here. You just use this syntax, normal CDF, normal cumulative distribution function. It's on the calculator's second function, distribution, and the second option is normal CDF. Lower endpoint, upper endpoint, and then specify the mean and standard deviation. So in this case, to find the area between 4 and 12 inches, or the number of fish between 4 and 12 inches, normal CDF 4, 12, the mean of the distribution is 10, the standard deviation of the distribution is 2, and hit enter and you'll get this. And area between 4 and 12, basically you got this right here using the rule, and you'll find that the answer here is not quite exactly the same. It's a little more accurate because the calculator's got a little more accuracy than the rule of thumb. And down here I think they even ask you the one you did the estimate for. So see if you don't get pretty close, even though you have to eyeball how much of area is in there. See if the calculator doesn't agree with you pretty well. Okay? In each of these problems, they're just giving you a normal distribution. Draw the sketch first and shade an area underneath the curve, and then use normal CDF to answer the question. You are going to have some questions where you're asked for something that's got infinity in it. What percentage of European men are shorter than 5 feet? So that one's going to look kind of like this, where the mean is at 66. Oh, pardon me. The mean was at 70, and the standard deviation was 3, and your picture's going to be, hey, you know what? Can I pretend I didn't do that? Let me draw it really small here and try to do it better. We've got this curve here. The center is 70. 5 feet tall is 60, so that's down here. But you're trying to find this area that goes down to negative infinity, right? So your setup for that one, and I'm going to write it in the wrong place, but the setup for that one is going to be normal CDF, lower endpoint, upper endpoint, mean, standard deviation. But the upper endpoint is positive infinity, right? So our rule of thumb for that is, negative infinity. Negative infinity, we're going to approximate this with the mean minus 10 standard deviations. So basically, just take 70, the mean, and subtract 30, 10 times the standard deviation, and you can use 40 in here for negative infinity. You can even punch in 70 minus 10 times 3 right in your calculator, and it'll do it for you. Okay, I'm not going to do too much with the backside, but let me just get you a little bit started on this. INV norm is the other calculator function that you've got, and you really need to draw the picture, be in the habit of drawing the picture to know whether you're using normal CDF or INV norm. When you draw the picture and you actually have a known area, like you're given the area under the curve, but you're trying to find the value on the axis, that's when you need to go backwards and use INV norm. It just means inverse norm. So an example here, they say, what height represents the first quartile of European men? Again, the basic picture is this bell-shaped curve centered at 70, but the first quartile is a value down here on the axis that has 25% of the observations, or 25% of the area to its left, right? There's 25% there, another 25 here, another 25 here, and another 25 out here. That's what the first quartile is, that's what the last quartile is. Since you want to find the value on the axis, you need INV norm. And so here's the setup. You're just asking the calculator what value on the axis will have this amount of area to the left under the curve. So it's area to the left and then you tell it the mean and standard deviation. And the number that comes out here will actually be a value in inches. It'll be the height of a European male who would be taller than 25% of the population and shorter than 75, the top 75%. Okay, I'll cut out here. The last part's mixed practice, and it's going to throw in the functions for Poisson. And does it have any binomial examples in here? I think maybe it's just Poisson mixed with some other use of normal in here. Okay, have fun.